ever since its origin, all the way up to 1905. Classical physics had reached a point of such solidity that it wasn't questioned by anyone. Actually, on the other hand, the theory of electromagnetism was questioned because of one particular fact related to the speed of light. And I'm referring to the fact that if we consider Maxwell's equations, as you should know, from these Maxwell's equations one could derive the wave equation. So we have the Laplacian of the field, which can be either an electric field or a magnetic field. So I can put, for instance, the electric field, and this is equal to 1 over the speed of light squared, d squared e over dt squared. This is the famous wave equation. And here's the speed of light, and according to Maxwell's theory, the speed of light is equal to 1 over square root of some constants which are related to the electric and magnetic field propagation in vacuum. But these two are constants in every frame of reference. So this must mean that if this is true, then c is a constant in every frame of reference. And physicists were puzzled by this because according to Galileo's theory in classical mechanics, which had been always right, if we have a frame of reference in which we have space in the ordinates and time in the abscissa, x is just one variable, so we have one-dimensional space for sake of simplicity. We have an object that starts at t equals 0 and it moves along the x-axis. If at time, let's say t, the object is here, we can also choose to use another frame of reference which has different axes like x prime and t prime. And of course, when the object is moving, x prime is always equal to 0 because it's fixed onto the object, whereas x can vary, right? So if the object is moving in the positive direction of the x ordinates with velocity v, then x is equal to v times t if we want to describe the motion of the object according to the frame of reference xt. Whereas according to this other frame of reference we have x prime equals 0, right? So this means that the speed measured in this other frame, which has a velocity v, is equal to 0 because we have to do a subtraction here. So the speed here is just v minus v, so that's 0. It's the speed of the object in this frame. If this frame of reference were moving not with the same velocity of the object, then the object would also move according to this frame of reference. So let's suppose that the object is moving relative to each of the two systems, to each of the two frames of reference. So if the speed of this frame of reference is v prime, let's say, and the speed of the object is v, of course the speed measured by this frame of reference x prime t prime will be not v minus v obviously, but it will be v minus v prime, right? So as you can see, there is a very simple law to transform a velocity in a velocity relative to another frame of reference. So this simple law apparently doesn't work for the speed of light, which must be constant. So there's no such thing, according to classical mechanics, as an absolute speed. There must be something like this, some kind of law that helps us relate a velocity from one frame to another frame. It's a very simple law. So according to some physicists' ideas before the 20th century, they thought that there was something wrong with Maxwell's theory. They were searching for instance, the so-called ether, some kind of particular medium through which light would propagate. But according to experiments, this new medium was never found. So there was something that physicists couldn't grasp. And that something was solved by Einstein, and we will dig deeper into how this happened.